Welcome back, everybody. We are up to lesson 15 now of Unit 6. We're still talking about trig graphs, specifically the midline, the amplitude, and the horizontal shift, those three things. I did add some things here to the bottom of the lesson notes about how to figure out the midline and the amplitude from the graph. Okay. So to find the midline, remember, the midline is halfway between the highest and the lowest y value. So if you identify the largest and smallest y values, add those two numbers and divide by 2, that will give you that horizontal line in between. And of course, the amplitude is just the distance from the midline to that high or low point, the max or the min point. So with that in mind, let's go ahead and quickly go to the examples for this lesson. In this case, we are matching graphs with equations. So we're matching graphs with equations, okay? So the first one is negative cosine of theta. Okay, now we know that cosine of theta, we should know from the past that cosine starts at 1, goes down to -1, comes back up to 1. So starts at 1, down to -1, and then up to 1. Now the negative of that is just going to be everything is flipped. So instead of starting at 1, it'll start at -1, go up to 1, and come back down to -1. So the negative just flips everything. And the only one that makes sense in this case is graph D. Okay? So instead of starting at 1, it starts at -1, it goes up to 1, and comes back down to -1. And of course, we can check on Desmos. If we check on Desmos, notice for each of the equations I put in x's instead of thetas, but you can see it does match that graph D. Okay, so that is the answer to number 1. Number 2, we have 2 sine theta minus 3. Okay, so 2 sine theta minus 3. So let's go back and look at our lesson notes really quick. Okay, remember the midline is a horizontal line that runs halfway between the high point and the low point. That midline is that plus or minus after the parentheses. In this case, that is going to be -3, which means that halfway point between the high and the low point should be at -3. So that's what we're going to do, is we're going to check here. All right, if I look at, for example, graph A, we'll start with graph A, is -3 the halfway point? Is -3 the halfway point between the high and the low point? It does. The 2 in this case, remember, is the amplitude. The amplitude, if we go back to our lesson notes, is the distance between the midline and the high or low point. So if I count the distance, it should have a distance of 2. Well, here's -3, -2, -1. So that does have a distance of 2, which means the answer to number 2 is going to be A. And if we double check that on Desmos, so here's the graph for number 2, we can see it does indeed match up with graph of A. Okay. Number 3, y equals cosine of theta plus pi over 2. So cosine of theta plus pi over 2. So notice in this case, the amplitude is 1. Okay. And since there's nothing after the parentheses, the midline should be 0. Okay. So, for example, A can't be the answer to number 3 because it doesn't have a midline of 0. B can't be the answer to number 3 because it has a midline, it looks like, of -2. Okay. It has a midline of -2. So the only possible answers are going to be C or D. C or D. So what does this pi over 2 mean? Well, when we add something inside the parentheses, that tells me the horizontal shift. So in this case, the C value is pi over 2. So that is positive. The horizontal shift is that many units to the left. That many units to the left. Okay? So that means that at that means that this is going to be the graph of cosine shifted pi over 2 to the left. So normally cosine will start at 1, at 0 degrees will start at 1 and then go down to 0, okay? But in this case, it's going to start at 1, but that's going to start at negative pi over 2. So it's going to start at negative pi over 2. So if I look at, for example, here, okay, notice it's 0 at 1. So that means if I were to continue the pattern at negative pi over 2, it's going to be at 1. So it looks like the answer should be C for number 3, but let's double check on Desmos. Okay, so it's 0 at 0, and it's at 1 at 3 pi over 2. And if we check that, that indeed is the case. So number 3 is C. Okay. All right, number 4, 3 sine theta minus 2. Okay, so remember this number after the parentheses tells me the midline. So which one of these has a midline at -2? The only one that has a midline at -2 is B. So 4 has to be B. Okay, because B is the only graph that has a midline at -2. And if we double check on Desmos, it should match up, and it indeed does. It indeed does. Okay. Number 5, sine of theta minus pi over 2. So notice here, when it was theta plus pi over 2, that meant pi over 2 to the left. In this case, it's going to be pi over 2 to the right. Now, this time it's sine instead of cosine. So remember the cosine graph, remember, it goes from 1 down to -1 and back up to 1. The sine graph starts at 0 and goes up to 1, down to -1, and then back up to 0. So it starts at 0. At 0 degrees or 0 radians, the value of sine is 0. Now this is going to be pi over 2 units to the right. So that means that theta equals pi over 2. The graph should have a value of 0. Okay? And then, so the cycle just starts at 0. So it goes up to 1, down to -1. And if we were to continue, it would come back up to 0 over here. So the answer to number 5 is going to be D. Let's just double check on Desmos here. Okay, and it indeed does match. So that is the answer to number 5. Number 6, now we're taking the sine graph and now we are shifting it pi units because of this pi here, but it's going to shift because it's positive. It's going to be shifted pi units to the left. pi units to the left. So if we think about sine starts at 0, so pi to the left means it's going to be 0 at negative pi. And then from there, it's going to go up to 1, and then down to negative 1, and then back up to 0. So the only one that makes sense here is graph C. If we check it, okay, if we check it, it does match. And we can see, if I go zoom out and go to negative pi, notice the cycle, instead of starting at 0, will start at negative pi. So it starts at 0 at negative pi and then goes up to 1, down to negative 1, and then back up to 0. Okay, so that's all that horizontal shift means. The purpose of this lesson again was to use our knowledge of midline, amplitude, and horizontal shift in order to match equations with their graphs, and that's exactly what we did. So that is it for this lesson.